Welcome back to this channel for practice problems for actuarial exams. My name is Krzysztof Ostaszewski. You can find information about me at smarturl.it/Jedi. My advice on how to pass actuarial exams is at smarturl.it/pass. This video channel is at smarturl.it/pass actuarial exams. Here you have information about online seminars and study manuals for exams PFM, IFM, and LTAM that I offer. I direct the actuarial program at Illinois State University. You can find information about it at smarturl.it/actuary. If you would like to offer a tax-deductible donation to support our students, please go to smarturl.it/help-ISU-actuary. Here's a problem for today for exam P on probability. Dwight Zeal and satellite component are musicians who travel to concerts around the world by flying a private jet. They decided to purchase a life insurance policy that will pay $1 million upon the first death of the two of them. The future lifetime in years of either Dwight Zeal or satellite component is exponential with hazard rate 0.0001 if death by means other than plane crash is considered. But the time until the crash of their plane follows the exponential distribution would mean 25 years and is independent of any other causes of death of either Dwight Zeal or satellite component. Assume that, unfortunately, nobody survives their plane crash if one happens. Let W represent the time of the first death. You are given that the present value of the benefit paid on this policy is $1 million times e to the minus 0.05 W. Find the expected value of the death benefit payment of this policy. So the expected value of this expression that we have here, $1 million times e to the minus 0.05 W. And here's the solution. Let us define the following random variables. X is the time and death of Dwight Zeal by causes other than their private plane crash. Y is the time until death of satellite component by causes other than their private plane crash. Z is the time until death of Dwight Zeal and satellite component as a result of their private plane crash. Then the time until the first death is W equals minimum of X, Y, and Z. Therefore, the survival function of W is the property that W is greater than W, and it's equal to the probability that X is more than W, Y is more than W, and Z is more than W because because the random variable W is the minimum of X, Y, and Z. So all of them have to be greater than W if the minimum is greater than W. Actually, the two conditions are equivalent. Because these are independent random variables, the probability of the intersection of the three events is a product of probabilities of them, and that's a product of their survival functions of X, Y, and Z. And that's equal to e to the minus 0.0001 W times e to the minus 0.0001 W times e to the minus W over 25. And if we multiply it out, this is equal to e to the minus 0.0402 W. Well, the survival function, if we take its derivative with respect to W and put a minus sign in front of it, will give us the density of the distribution we're studying, and that density is equal to 0.0402 times e to the minus 0.0402 W. And the expected value of the death benefit is just the expected value of $1 million times e to the minus 0.05 W. So $1 million times the integral from 0 to plus infinity of e to the minus 0.05 W times 0.0402 times e to the minus 0.0402 W dW. Okay, we put this 0.0402 in front, multiplied by $1 million, and we get 40,200. And then combine the two exponentials, and if we multiply them out, we get e to the minus 0.0902 W dW. The integral of that is the mean of an exponential random variable with hazard rate of 0.0902, and that's of course 1 over 0.0902. So the value of this 40,200 times the integral is simply 40,200 over 0.0902, and that's approximately Um, 445,676.2749. And that's answer C. Please remember this is copyrighted material. The problem was written by me and the solution is mine. All rights reserved. Reproduction in whole or in part without express written permission from the author is strictly prohibited.